So we just learned how to set the boundaries for our bins, but let's just say we don't know necessarily ahead of time what those boundaries should be. We just want to cut our data into a specific number of bins, like we just want to create 5 bins or 10 bins. So we can do this as well. Again, we pass in the series as the first argument. And then for the bins parameter, we just put a number over here. And this will cut it into 8 bins. They'll be equally spaced from the smallest to the largest. So here is 8. It's going to create 8 equal size bins. So this distance will all be the same. You can see the categories over here. And we'll call it, assign it to S. And if you want to get the categories, you can just use the cat accessor so you can view them, although they do show up over here in the results, so you don't have to do that right now. Okay, so that is good, and then we can let's go ahead and count these, how many times they appear. So the only issue here is that even though, like for instance, we have actually a category here that has 0 houses in it, so the data is sparse after we get to houses greater than 3,000 square feet, and so this one only has 1 house in this area. This one has 0 in this band over here. But the intervals are all the same distance. So approximately what looks like 663 or something. That's going to be their distance. So that's what Pandas figured out will create equal sized bins. So this is another option if you don't want to set the boundaries yourself. So it's perfectly valid as well. And we'll see how QCut can actually get bins such that they're the same number in each bin, instead of this, that we're not guaranteed to have any rows in a particular bin. All right, so something else that you can do is you can label the bins. Instead of having them as numeric intervals, you can have them as labels. So do pd.cut again. This time we'll cut ground living area. And this time we'll, just to show you this, we'll say 1,000, 3,000. Make this 1,500. So if you press Shift Tab Tab, if you do labels, set the labels parameter, put this on its own line. So bins equals labels equals. Now you can give it a string label. So I have 4 endpoints, which means I have 3 bins. So small, medium, large. And actually, so one of the houses has more than 5,000, so I have to be careful here. And in fact, if you give a label that's less than the max, that will create a missing value. So you don't want to do that. So let's just make this 10,000. So small, medium, large. So now I get string labels over here. So that's pretty cool. You can also return the bins. So there's a return bins parameter. So if you want to know what those bins are, you have to set this equal to true. It returns a tuple, you can see over here. So you can it'll return the series and then the bins like this as a tuple. And then here are the actual bins. It turns as a NumPy array. So you can see how it was cut. Of course, we gave the labels itself so we know what the bins are, but let's just say we wanted to do 3. So we don't know ahead of time what those bins are going to be. So now we can get this and it'll tell us, all right, this is what Pandas used as the bins. All right, so now this is an ordered categorical series that's returned with 3 unique categories, small, medium, and large, and then you can call value counts on this. And you can see the counts of those different categories. So just another usage over here. You can label your intervals instead of using the intervals themselves with labels.